Hello, how to solve for s in this equation? 3 to the power of x plus 9 to the power of s is equal to 27 to the power of x. Solution. Here we have 3 to the power of x plus this 9 to the power of s can be written as 3 square to the power of s is equal to 27 to the power of s can be written as 3 to the power of 3 to the power of x. Then we can bring this inside here. We have 3 to the power of s plus 3 square to the power of s minus 3 to the power of 3 to the power of s is equal to 0. Take note of this, that if you have a to the power of m to the power of n is equal to a to the power of n to the power of m, which is equal to a to the power of mn, then this can be written as 3 to the power of s plus 3 to the power of s all square minus 3 to the power of s to the power of 3 is equal to 0. Let 3 to the power of s is equal to a. Then we have a plus a square minus a to the power of 3 is equal to 0. Then let's rearrange this. We have minus a to the power of 3 plus a square plus a is equal to 0. We can divide all through by minus 1. So if you divide minus a to the power of 3 by minus 1, we have a to the power of 3. Then if you divide plus a square by minus 1, we have minus a square. And if you divide plus a by minus 1, this becomes minus a is equal to 0. Now here a is common. Let's bring it out. We have a bracket. If you divide this by a, we have a square. Then minus, if you divide this by a, we have a. Minus, if you divide this by a, we have 1 is equal to 0. There are two cases from here. The first case is a equal to 0, and the second case is a square minus a minus 1 is equal to 0. Then from here, a is equal to 0. That is first value of a. And here, a square minus a minus 1 is a quadratic equation. Let's solve this using quadratic general formula. A is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. And from this equation, a equal to 1, b equal to minus 1, c equal to minus 1. So let's consider this discriminant first. And b square minus 4ac is equal to minus 1 square minus 4 multiplied by 1 multiplied by minus 1. Then this is equal to minus 1 square, that is 1, minus 4 multiplied by 1 multiplied by minus 1. This is plus 4. Then b square minus 4ac is equal to 5. Now let's plug in this here. The equation becomes, we have a is equal to minus bracket minus 1 plus or minus square root of 5 divided by 2 multiplied by 1. Then a is equal to minus times minus 1, that is 1, plus or minus square root of 5 divided by 2 times 1, that is 2. Therefore, a is equal to 1 plus square root of 5 divided by 2, or a is equal to 1 minus square root of 5 divided by 2. So all the values of a are, but 3 to the power of s is equal to a. Then therefore we have 3 to the power of s is equal to the first value of a, which is 0, and 3 to the power of s is equal to, here we have 1 minus square root of 5 divided by 2, and lastly 3 to the power of s is equal to 1 plus square root of 5 divided by 2. But from here we have 3 to the power of s, this is 0, so 3 to the power of s cannot be equal to 0, this is undefined. Then here 3 to the power of s is equal to 1 minus square root of 5 divided by 2. This is positive and this is negative, so this is rejected. Then here we have 3 to the power of s is equal to 1 plus square root of 5. So this is the real solution, and the whole of this is called golden ratio. From here, let 1 plus root 5 divided by 2, which is the golden ratio, equal to 5. So we have 3 to the power of s equal to 5. Then here, let's take the log of both sides. We have log 3 to the power of s is equal to log 5. And we have, if you have log a to the power of b, this is equal to b log a. Then this can be written as s log 3 is equal to log 5. But we are looking to the value of s. Let's divide both sides by log 3. Divided by log 3, this divided by log 3. This will cancel this. S is equal to half log 1 plus square root of 5 divided by 2 divided by log 3, because our phi is equal to 1 plus square root of 5 divided by 2. Therefore, s is equal to log 1 plus square root of 5 divided by 2, which is the golden ratio, then base 3. And this is the final answer. I hope you enjoyed the video. Thank you for watching. Please don't forget to like, share, comment, and subscribe to my channel. Bye.